Alright chaps, simple harmonic oscillation. Let's continue on from what we were talking about in class. Simple harmonic oscillation. Harmonic oscillation is when an object is basically going up or down, up or down, up or down, just like this spring is. But the caveat is, the thing that makes it harmonic oscillation is when the restoring force is directly proportional to the distance that it's displaced. In this mass spring system, when you think about it, the force of the spring acting up is going to be increased the more it stretches down because of Hooke's law, which is force equals negative kx. Same with the pendulum. With the pendulum, the higher the angle, the more displaced it is from the front, the greater the force acting down on that. But I'll prove that to you in a second. Okay, how do we measure oscillations? The way we're going to measure oscillations, you can measure two things. The first one is period. That's what you were measuring in class. You were measuring basically the amount of time, and that's why it's a capital T for the symbol, the amount of time it takes to do one oscillation. If you were looking at the pendulum, how long it takes to go from one end to the other and back again. If you're looking at the spring, how long it takes to go to the bottom up to the top again. So of course the unit is seconds because you're measuring time, and it is a scalar. The other way you can measure it is to measure frequency, which is how many oscillations occur in 1 second. Basically what you would do is you would set your stopwatch for 1 second, see how many times the pendulum swings back and forth in that 1 second. Or you can, set your stopwatch for 10 seconds and see how many oscillations it is in 10 seconds and calculate the frequency by oscillations divided by time. Quick elementary example, if you were going ahead and measuring 6 back and forths in 10 seconds, then you would go 6 divided by 10. The unit is in hertz, which is actually inverse seconds. So 6 divided by 10 will be 0.6 hertz, meaning 0.6 oscillations per second. And again, that is a scalar. All right, now measuring oscillations. There are two things we need to know about measuring oscillations when it comes to frequency and period, and they are the inverse of each other. This makes sense when you really think about it. So I gave you this is the equation: the period equals 1 over the frequency, or you can rearrange that to say the frequency equals 1 over the period. But think of it: if an oscillator has a frequency of 4 hertz, that means there are 4 oscillations every second, then that must mean that every oscillation has a period of going there and back of 1/4 of a second, or 0.25 seconds, right? Same, pick another number, 3 hertz, then that means 3 oscillations in 1 second. That means each oscillation is 1/3 of a second. So it makes sense that they're inverse of each other. And the only other thing I want you to know about is amplitude. This is the maximum displacement of the oscillator. So the amplitude for the guys working on the pendulum was how far you pulled it away from its equilibrium position where it would have rested. The guys with the spring, the maximum distance you pull it on the X, that is the amplitude right there. I'm going to stop it here and record a new video, so please watch the second video. I'm just breaking it up. It makes it easier to upload. Right, thank you.